So here's your interim exam review. Please make sure, my best advice for you is that you don't just watch this video, that you actually try to go and do all of the problems on your own without looking at anything. If you can do that, then you should be in great shape for your interim. Remember, it is on Monday, March 10th. It will consist of 15 questions and will count as 5% of your grade. Again, it can also replace one test grade. So for the first two, we're asked to state the conjugate of each complex number. To state the conjugate, all we need to do is look at the I part and only the I part and change that sign. And since it's negative for I, I'll change it to positive for I. And then we should always try to write complex numbers in the form A plus BI. Try to put that BI, the I part in the back. So I'm going to leave the real part, the -3, alone and just drag it to the front. So then for number two, again, leave the 2. You just change the I part. So just change the sign of the I part when it says conjugate. For number 3, we're going to multiply. And if you'll notice, 3, those are examples of conjugates, 4 plus 7i and 4 minus 7i. So something special happens when you multiply, but just go through the motion. 4 times 4, 4 times negative 7i, 7i times 4, and 7i times negative 7i would be negative 49i squared. But we need to know our powers of I, especially I squared. And I squared is -1. So negative 49 times -1 would become positive 49. Now I'm going to combine like terms. I have 16 and 49. So 16 plus 49 is 65. And then whenever you multiply conjugates, you should notice that your i's will disappear. So -28 plus 28 is 0. My answer is 65. When you multiply conjugates, you end up with just a real number. And for number 4, another multiplication problem. I'm going to write this one out for you. That might help. Again, I'm just multiplying the -2 by everything in the other parentheses. So -2 times -6, and then -2 times -4i. Then I'm going to multiply the -4 by everything. -4, -4i times -6, and -4i times -4i. We're out of room there. All right, now I'm going to do that multiplication. So -2 times -6 is 12. -2 times -4i is positive 8i. -4i times -6 is positive 24i. And then on the end, -4i times -4i is positive 16i squared. And whenever you see that I squared, just think to yourself, if 16i squared is 16 times -1, well, that's just going to make this whole part right here -16. And combine like terms. So 12 minus 16 is -4. And 8i plus 24i is 32i. Or once you got the -4, we could come over here and pretty much know that C has to be our answer. For number 5, we're looking at a subtraction problem. Remember, subtraction problems should distribute the negative. I like to write myself down a brand new problem. I'm going to leave the first complex number alone. And then now the 18 becomes negative, and the -9i becomes positive. A minus in front of the parentheses will change the sign of everything inside. And then we're going to combine like terms. So I'm going to start with my real numbers, which are right here in the middle this time. So 6 minus 18 is -12. And then 17i plus 9i would be 26i. So -12 plus 26, you should choose B. And for number 6, I'm just going to take it piece by piece to get started. So I'm going to bring down this negative sign because it's in the front of that radical. And then the square root of 36 is just 6. We have a plus sign. When I go to the parentheses, again, the square root of -4. This is kind of where we need to know our definition of I. So I could split up -4 as square root of -1 times the square root of 4. The square root of 4 is 2. And again, the square root of a -1, or a lot of times we kind of just say, if it's a negative, the negative comes out, as an I. And then we had times 6. We'll kind of keep working from there. I'm bring down my -6. And then 2I times 6 would be 12I. Number 7, multiplication problem, but it's excellent. It's simple distribution problem. So we're going to do I times 5I and I times 10. So 5I times I will be 5I squared. And then I times 10 is positive. We have 10I. But anytime you see that I squared, think about that as being -1. And 5 times -1, you need to write it off to the side. 5 times -1 would make this -5. And then we'll just write our answer nice and pretty. And real goes first. I should go in the back. For number 8, a multiplication problem. Again, it's 2 minus 4I squared. Please remember that you don't just square the 2 and you square the 4I. Again, 2 minus 4I squared means that it's there 2 times. So please write it out 2 times. And then now it's really just like number 4. We're going to multiply 2 times 2. 2 times -4I. -4I times 2. And then -4I times -4I. If it helps, write it out to the side so that you can really see what that's going to end up being. It's going to be positive 16I squared. Once again, we got that I squared. We're going to remember that 16 times -1, that's what I squared is, would be -16, and then combine your like terms. So 4 minus 16, and then -8I minus 8I is -16I. Combo, we got a little multiplication going on and subtraction. So I'm going to start with this multiplication here. I'm going to distribute 2I just to the parentheses that it's on. So 2I times 7 would be 14I. 2I times -4I, -8I squared. And then same as before with that subtraction problem, let's distribute the negative. You know, put a 1 here. You're really just multiplying by -1. That's going to change that to -18 plus 3I. And then combine like terms after. Let's go fix that I squared. -8 times I squared, which is -1, would make this become +8. And then now I'll combine my like terms. So I've got -8 and -18. Sorry, not a -8. +8 minus 18, -10. And then 4I plus 3I. Number 10, it says, which expression has the same value as 6 plus 4I squared? So the first thing we might need to do is go and actually work out 6 plus 4I squared. And just like number 8, when you multiply this out, please write it twice. Do not just square the 6 and the 4I. You're going to be leaving out some stuff. So when we do this multiplication, 6 times 6 is 36. 6 times 4I is 24I. You'll notice that if you do this process, you end up getting your outside inside terms, or the 2 middle terms, end up being the same thing. And then we have 16I squared. And I'm going to fix my I squared. That's going to be -16. And the I squared just simply changes the sign of whatever it's with. And then combine like terms. So 36 minus 16 is 20. And then 24 and 24 is 48. So we're looking for something that gives us that same answer. So if I kind of look at my choices, I know it's not D, because that's not going to work. 6 plus 4I and 6 minus 4I, that's actually, if you go and work that out, it's going to give you, and I'm going to show you that work here. Do it down here. If you work that one all the way out, it's going to give you 36 minus 24I plus 24I minus 16I squared. And so for this one, this becomes plus 16. Then I would do 36 plus 16 for this one, not 36 minus 16. So right there, I know that this is not going to be it. But if you were doing this one, it would actually give you 52. So I know that it's not C. And then now we have our addition subtraction. Addition would be kind of quicker to check. So if you do 28 plus 24, if you're combining like terms, that's not going to make 20. So it's not B, it must be A, but just double check it. And if you're looking at choice A, we have 24 plus 30i. Can go and distribute that negative. So now it's going to be minus 4 plus 18i. And then if we look there, 24 minus 4 is 20. 30 plus 18 is 48. So that one works. A is the one that matches. For number 11, which value of B makes the statement true? So this is where we're going to first kind of simplify the problem a little bit, or at least distribute that negative. So make it minus 12 plus BI. And then now all we have to do is look at the I parts. I don't need to look at anything else. So I'm going to look here. I have 3i plus bi equals 7i. So as I bring down the I parts, I'm just going to bring down the numbers in front. So 3 plus b equals 7. And then we solve this really simple equation by subtracting 3 from both sides to get b is equal. Number 12, solving our inequality. So for this one, again, you can really use Desmos. I would encourage you to kind of at least get it started algebraically. I'm going to move this over just because when I go to Desmos, I want to be able to look at the x-axis. So I'm going to subtract 12 from both sides and get minus 42. And again, I'm going to ignore the inequality right now. And just really right here, I'm figuring out what are my roots? What are my x-intercepts? So factors of 42 that subtract to give me 1 are 6 and 7. It needs to be a plus 7 and a minus 6. And then when you solve, you get 6 and negative 7. Now, if you know me, you know I don't like to go to Desmos for everything. I like to just kind of go ahead and sketch those right here. And then know that if it's a quadratic, it's going to be a parabola-shaped graph crossing through negative 7 and 6. Because it's a positive in the front, I know my parabola opens up. And then now I go and I grab that inequality. So it says greater than would be the sections that are above. So it would be everything to the right of 6 and everything to the left of negative 7. So to the right would be greater than, and to the left would be less than. So then I go over here and look at my solutions. I'm like, oh, I don't have something that has less than and greater than. Well, think about your interval notation. Everything from negative infinity to negative 7. And then everything from 6 to infinity. Kind of look at it in interval notation as well. So I want negative 7, or negative infinity to negative 7. Not that, and not that. And then you'll notice the difference between the two solutions that are left are the parentheses in the bracket. Because I don't have an equal sign, I want to choose C. Number 13, same idea. It says the quadratic equation given there represents the height of a baseball after it's thrown in the air. Let x equal the time in seconds and y equal the height of the baseball in meters. When is the baseball at least 10 meters high? So the first thing we want to do is write that inequality. So we're going to take what they gave us. But then the problem says at least 10. So at least 10 is greater than or equal to 10. And then I would do the same thing that I did on number 12 before I go to Desmos, just to make it look a little bit easier. I'm going to move that 10 over here. I'm going to subtract 10 from both sides. It's going to give me negative 4. Again, I'm going to ignore that inequality for now. And then what I need to do is I need to find my solutions. I need to find my roots. So for this one, I actually do like to use Desmos just because it's not as easy to factor as the one before. And so, you know, it's not a quick factoring problem. Use Desmos. It does factor. You could actually take out a GCF of negative 2. And then after you take that GCF out, sorry, 1 second, let me find where my Desmos went to. Once you take the GCF out, then it becomes a kick to the back problem. All right, so hopefully you can see Desmos now. So I'm going to type in the negative 4x squared plus 10x. Again, I'm going to do my 0 version, and I am going to go ahead and type in that inequality. So again, at least was greater than or equal to 0. And so the nice thing about Desmos is it will shade for you. So it's shading in between 0.5 and 2. So 0.5 and 2 is what I would get if I actually kind of used the quadratic formula or factored it. And then I know that it's going to be above in between those two numbers. So then I'm going to go back and write that solution, and I'll kind of show you a picture to help. Draw the same picture I drew before. And my roots are 1/2 and 2. That's where it crosses the x-axis. This particular parabola, since it's a negative in the front, it's going to open down. And then greater than means everything above. So it kind of shows me that I want everything in the middle of 1/2 and 2. And so you can write that answer 2 different ways. You can write it as interval notation, where you just do 1/2 comma 2. But because at least means equal to, you should use brackets around that, or you would do 1/2 less than or equal to x less than or equal to 2. Again, when we use the word at least, we have to know to use the equal sign. For number 14, we're going to solve that equation. And if you have just an x squared or a parentheses squared, like you see on number 16, please use the square root method. So that just means we want to get this by itself. So to do that, I'm going to add 2 to both sides. That's going to leave me with 4x squared equals negative 13. Then again, get x squared by itself. So let's move the 4 over. Now we're going to square root. So square root. And to square root a fraction, you're really to square root in the top and the bottom separately. So I'm going to do the square root of negative 13, think of them by themselves, and the square root of 4. Let's start with the square root of 4. That's the easy one. Square root of 4 is 2. And then the square root of negative 13, the negative is your I. We're going to leave the 13 because it's not perfect. And then because it was a quadratic, because it's x squared, fundamental theorem of algebra tells us we got to have 2 answers. So we want our plus and minus. So plus minus I radical 13 over 2. For number 15, same thing. It's got an x squared. So I want to solve this by first moving that 152 to the other side. So I'm going to subtract 152. That's going to give me negative 152. Divide by 19. Now for this problem, again, always check your fraction. If, like on the one before, 4 does not go into 13, so I left it 13 at the 4. But for this question, 19 divides into 152 evenly. It will give me negative 8. So if you can get a whole number, great. If not, leave it as a fraction. Now I'll do my square rooting. Two answers, so plus minus. All positive numbers have 2 roots. And then now we have to work on the square root of negative 8. So think about it this way. Square root of negative 8 is the square root of negative 1. And then 8 has a perfect 4 in it. And then times 2. So the square root of negative 1 is I. The square root of 4 is 2. And then we have to leave this 2. So my answer, plus minus 2I radical 2. 16, I can also use the square root method for this one. So anytime, again, there's a parentheses squared, use the square root method. I would get the parentheses by itself, and that's already done. So now I can square root both sides. Get x minus 8. The square root of negative 25 would be plus and minus 5i. And then to finish it, we're going to add 8. And 8 and 5i are not like each other, so I just put the 8 in the front and real in the front and your imaginary in the back. So 8 plus or minus 5i. B would be our correct answer. And then for number 17, now we have a quadratic that has an x squared and an x. So for a problem like this, you either want to try to factor it or use the quadratic formula. This one will not factor, so I'm going to go ahead and do the quadratic formula. If A would be 1, B is 6, and C is 13. Always make sure it's set equal to 0 before you pick out your A, B, and C. Then go to your formula sheet to consult your quadratic formula. It's negative B plus or minus the square root of B squared. I'm going to go ahead and square B. 6 times 6 is 36. And then minus 4 times A times C all over 2A. And we're going to simplify it. Again, I'm going to leave the number in the front and the number on the bottom all by itself. I'm just going to my calculator and typing in 36 minus 4 times 1 times 13. Should get negative 16. And then we're going to keep going as far as we can. Well, negative 16 is the same thing as 4i. So again, we can square root 16 and get 4. And then the negative is your I. And then now I can keep going. I can reduce. And to help you reduce, maybe split these up. Write it as negative 6 over 2 plus minus 4i over 2. And reduce those fractions individually. So negative 6 over 2 is negative 3. And then 4 over 2 is 2. Negative 3 plus or minus 2i would be our simplified answer. For number 18, so it says the table models the distance that a car with locked brakes gives while coming to a complete stop after traveling at a certain speed. We're going to determine the quadratic regression, and then we're going to use that regression to predict the distance if the car skidded. The distance skidded if a car was traveling 73. So this is a completely Desmos problem. It tells us quadratic. I kind of mentioned on the last test, like quadratic is the one you got to know. And I appreciate if you tried the cubic or a quartic, but quadratic. So to go and do this in Desmos, the first thing we're going to do is click on, and just give me a second, I'm going to make sure that this is the screen you're looking at. Yep. Click on the plus sign, click on table, and enter your data. And again, enter your data very carefully. Make sure all your numbers are as they appear, like read them over 2-3 times if this is a test question. Because if you type one in wrong, your A, B, and C will not work out to be what they need to be. So that's the first part. And then you can click right here on the little magnifying glass where it says zoom fit. And you can kind of zoom in a little bit, and I can kind of see that shape. And maybe I'm not sure if it's a quadratic, but again, the question says quadratic regression, so go with quadratic. Now we just have to know how to type it in. Again, it's y1, little tilde symbol, ax1, and then square. And I'm not doing anything special to get those ones to drop. I'm just typing in ax1, and then bx1 plus c. So I'm typing in my quadratic, ax squared plus bx plus c. And you can find that on your formula sheet. You just have to know to type in the tilde and to put the ones. And again, the reason we use the ones is because our table is called x1 and y1. But then I'll look over here and see that's a pretty good fit. Those points are right through, or that line is right through those points. Look at this r squared. This r squared is 0.9999. You don't get any closer to 1 than that. Again, the closer r squared is to 1, the better your line is. All right, now we're going to use that equation. So I would write down on my paper y equals 0.0419. I'm going to go, it doesn't tell me on the review how many decimals to round to. So, 3 is good. If you want to make that a 2, I would be okay with that if you want to stick to 3. And then plug in 73 for your x. And then I'll go back and write this on our review in just a minute. And then our b value is 0.049, and plug in 73. And then our c value is negative 3.651. And it should, oh, not x squared. I want to square the 73. So replace your x with 73, and I'll go and write this one down in just a minute. And so then it says use your regression to predict. So 223.7, or if you kind of want to round because your table is all in whole numbers, we could call it 224. So type in your data, know that equation, because if you type in that equation, it gives you your A, B, and C for that regression equation. We use Desmos. We found that our equation was y equals 0.042 x squared, 0.049x minus 3.651. And then we plug in 73 into that. So when you plugged in 73, I'll kind of write it out for this one. I just type this in right here. Square 3. Ended up giving us I think 223.7. So I would just kind of say here, since the rest of my data was whole numbers, I would probably say that it skidded 224 feet. $19 and $20. Make sure you know how to write down ordered pairs. So all we're looking for here is where they meet. So if I look at this linear and this quadratic, I see that they're intersecting at that point and at that point. So this one here would be the ordered pair 0, 2, and we do x's first. So I didn't go left or right at all, and then I went up 2. And then this would be the point 4, -1. So we're going to select all that apply. So I have my, sorry, I can't even read it. Was it 0, 2, 0, 3? Up 3 and 4, -1. 0, 3 and 4, -1. And then for this one, again, find those intersection points and then just carefully write down the coordinates. This one over here to the left, again, this is left 2, so -2, and down 1. And then over here, this is to the right 1 and up 2. So again, to list a coordinate, left, right, and then up, down. So -2, -1, and 1, 2. This is actually a test question, I think, back from your 5A test. Some of us missed one of those points. I'm going to stop there and then do the rest of it in another video.